Hi guys, and welcome to a new tutorial of Blender and geometry nodes. Today we are going to create a procedural feather in Blender. Let's get started. I'm working on Blender 3.3.1 and I decided to create this tutorial because I was working on another tutorial and I needed a procedural feather to my purpose, and I've seen few videos about procedural feather, and for this reason I decided to create one from scratch. So go up in the plus menu, General, Geometry Nodes, create a simple plane, Shift A, plane, click here to create a new geometry modifier, and lots of the parameters that we will use in this tutorial we'll need in the shading editor and not in the geometry system. This is like an experiment and I hope you will enjoy it with this tutorial. So first of all, press 1 to go in the front orthographic view. We will create a line, then another line starting from a different point and not the origin. Then we will use an horizontal line to create a profile space. Then we will use this space to save information about x values, z values. We will deform these points to create a shape like a feather, so like these for example. And in the meantime I will show you the shading result in the shading editor. We are not going to use particles or hair system, but only a simple deformed shape with lots of shading work. So first of all we need a simple curve line. We can select this node, Ctrl G to create a node group because I could use this node from other purpose or instantiate it lots of time with a different parameter in a more bigger environment. So we can drop the start, we can drop the end, we can delete from the group these two attributes, and we can export from the end only the z value in our group input. Collapse this node with H, select all these nodes, Ctrl J, F2, base, curve. Now we have two pieces of this feather. One is the base of the feather and the other is the rest of the shape of the feather. Now we will create the shading and the profile of the base. To create our profile curve we need a resample node to resample this simple curve line. We can link these together with the Alt right button, and we can use another group input node to export the resolution of this input, this resample curve. This is our length from 0 and this is our resolution from 1 is perfect. The full length we can insert 1, and for the resolution we can use 14 for example. Because we will use the resolution on the next part of the feather, I decided to multiply this resolution by 2 before linking in the count attribute of the resample curve. Then we don't want a single line or a cylinder as the shape of this base, but we want a shape like this. So the base is larger near the middle and then smaller at the start and at the end of the base. So to do this we can use the set radius, we can use the spline parameter to get the factor, so the value that goes from 0 to 1 along the curve. You don't see anything because we need to exit with a tab from this group node and set the length to 1 for example, and 14 for the resolution. Rename these in feather, tab to enter, the edit mode. This is our curve. Now we can use the factor and change the shape with a float curve node. We can set a simple shape like this for example, and use these for the radius of this set curve radius. Next we want to transform these in a physical shape with a curve to mesh, and we can link for a profile an arc with 360 degrees. Okay, we can press Shift Alt and click to see the result. We can decrease the radius to see better the shape. We can check a connect center here. Then we can create the UV map of this entire shape using the same technique used in a previous tutorial of my channel and other tutorial on the internet. So I can use a spline parameter and I can use the capture node on the base curve and a duplicate of these for the profile curve. I can link the factor here and here to save for each point the float value of the factor in this direction, and for the circle direction of the profile curve of this arc. Fill the caps. We can set the radius 0.01 for example. Next we can combine together the two parameters for the x and for the y values of the UV of this shape, and we can store this information in a new attribute of this shape. Select vector, link this UV information, and we can name it feather base UV. Now we can merge by distance for security reason the upper part, the lower part of this shape, and also the middle part of this shape, selecting here connected. And remember, using this technique, so the arc instead of a simple circle curve, you need to select here not the point but face corner, otherwise the shading editor will not be able to read the information, the correct information of the x and y values for creating the correct UV map and then the correct mapping of your texture or whatever. Now we can set the material of this shape, Shift Z to see the result, 1 to see the entire shape. We can hide the annotation, we can add a set material, and we can export the material in the group input to better select a material that you want from one feather or other feather. We can rename it in base. We can create the base material, feather base. We can select all these nodes, Ctrl J, F2, base, feather, and UV. Now we can go in the shading editor. You can see this shape here. Press 1 and we can import an attribute node and set here the feather base UV, where we have stored the information of the x and y information of this shape. We can separate, for example, this vector in x, y, and z, and use the x-axis, for example, in a wave texture. Using the x bands, we can set 3.3000. We can link these to a color ramp. We can change the color a little bit. For example, we can set these two colors, invert these, and link the color in a base color of this principal BSDF. Shift Ctrl click. You don't see anything because we need to go to geometry nodes, tab to exit from this group node and select the feather base. Now we can turn on the preview and voila, this is the result. Tab to enter in the workflow, enable the snap tool here. Now we can move these a little bit up to access to the rest of the feather. Now this is the base of the feather. We want to create a shape like this, for example, and to do this we need to create another curve with a new factor based with a new 0 starting point, and new 1 point. So we don't want the factor based like this from 0 to 1, but we want to start from a point in between and create a new curve with a new factor from 0 and 1. To do this, we can easily shrink the factor from this entire curve to a little curve starting from a point that we want. So in this case, we can use the sample curve to redistribute the value of the factor parameter on this curve based by a new group input attribute that we can add and name start. Is a float number that we can set 0.4 from 0 to 1. So the minimum 0 is this point and maximum is 1. So this point we can get the spline parameter to get the factor, the original factor, and we can remap this factor that we know start from 0 and go to 1 and remap these with a minimum of starting point and maximum of 1. We can link this result to the new factor, and here we have a new factor position that we can use to set position of our curve, linking the position in the position. We need to resample this curve using the same resolution attribute of our group input. So group input here, and we can link the resolution in this resample curve. So I have here 14 points and this means that we will have 28 points for the resample curve of the base of the feather, so this shape. But for our new curve, we will have only 14 points from this point and this point. You can see this curve because I can press Shift, Alt and click, and this is the original curve from this point 0 and 1. And if I press Shift, Alt, click on this set position, you see nothing because we need to exit from this and set a starting point more bigger. So we can set, for example, 0.2, and this is the new curve tab to enter in the group node, Shift, Alt and click to see the resample curve. Now we will use this curve with an horizontal curve to create the entire shape of one side of the feather. We can select all these nodes, Ctrl J, F2, feather, curve, G to move a little bit. Now I don't press the Ctrl H to hide this unused attribute because we will add more attributes to this group input node. So next we need to save on this new curve the information of the length of this curve, because we will use in the shading editor these values as the Z components create the subparts of the feather. So we needed to save this information for each point, and to do this we can easily get the spline parameter another time, and we can use the store name attribute to this resample curve, Shift, Alt and click. Now we have this result here, the temporary viewer, so press Tab and Shift, Alt and click. We need to rename this curve, so enter in this group node, select the group output, select curve, go here and rename it geometry. Now we can link this value here to the output, and we can save not the factor but the length, because we will have an horizontal pattern distributed on a vertical direction, and we don't want to stretch this pattern if I increase the length of the feather. I want to maintain the same proportional values of the pattern, and to do this I need to save not the factor from 0 to 1 but the length, because the length follows the relationship between the unit measure and the environment and the global coordinate system of my environment. So to do this I need to link the length, and we can set here the Z. Select these nodes, Ctrl J, F2, save Z map. We will add lots of these attributes in a way like this, because it will be more easy access to them in the shading editor and manipulate the pattern and the colors and the other stuff. The next attribute that we need to save is the thickness of the single hair of my feather. So we will have a pattern, a repeated pattern distributed in vertical direction, and for each hair I want to decide what thickness it needs to have. So we can duplicate these two nodes, Shift D, go here, we can set this thickness, and we can link these to the group input node. We can drag here in the section, and we can rename this value as the thickness. You will better understand how it works in the shading editor. So for now I set here 0.8 from 0 to 1, so I don't want gap from one hair to another hair if I set 1 for this attribute, and if I set 0 I want the maximum gap, so no hair at the end. I want to stay in between. Okay, rename this section in save thickness for all points. This is good. Now we can create the horizontal line to create the profile of the shape of one side of feather, and to do this we can use a curve line that is based by 2 points, the start and the end points, and we want to go on the x-axis and not the z-axis because we already have a curve on the z-axis. We need also for this new horizontal line the stored information of the x value, so the factor from 0 to 1. So if I press Shift, Alt and click, you have here the horizontal line, and I want to save the factor from 0 to 1 on each point of these to have the correct mapping of the UV for the entire square made by these as the profile curve on this vertical line. So I can import another time the store name attribute. We can import the spline parameter and save the factor here for the x information, okay, from 0 to 1. And in the shading result, you will see the x values going from 0 to 1. So here we have 0 and here we have 1. And for the z components, the z attribute that we saved before, we will have a 0 here and then 1 here. Now we can import the curve to mesh node to create this plane. Fill caps, Shift Alt click. This is our side, our first side of the feather. Now to see these values on the shading editor, we need to assign a material to this geometry. So we can import a set material node. We can create a new material that we can name feather. We can set this material here. We can go in the shading editor. We can add an attribute and set here X, Shift Ctrl and click, and voila, this is the values of the X information that we saved on the curve that Blender saved for each new line while profiling the vertical line. Okay, and for the same reason, if I set here Z, you can see the values from the bottom to the top of this entire shape. Now, next step, we can select all these nodes, Ctrl J, F2, feather, profile, and save X map. So I need to link these, and these to these, otherwise I will not have the thickness attributes saved on my vertices. It will be more clear very soon. Now we need to save another information. We have to distinguish what vertices are on the base of my feather and what is the boundary points of my feather. Shift Z to see these new points created by the profiling operation, and we want to save these points with a flag, with a check, okay, and we can call it boundary. And to do this, we can store a new attribute on this geometry. We can set this boundary for each point, and the value, this is not float but a boolean, a check that we want to set. And to do this, we need to make a mathematical operation on the index of each point. So if I set index and I set equal to 0 and link the result here, you can see only the first index has true in the boundary attributes. I don't want that. So to better understand what index I need to set here, I can use, for example, a set position to help me understand, and I can get the name attribute boundary. From this list I can select boundary, link the attribute on the selection, and increase, for example, the all the values of the offset. For example, with the shift I can increase these a little bit, and you can see this is the 0 index. If I increase these, I have 1 index here, 2, 3, 4, 5, etc. So this is 1, and because we need to save only this index, I can set if the index add 1 module 2 is equal to 0, I want the boundary. So I explain, these are our indexes. We have here 0, so 0 plus 1 is 1, and the module of these with 2 is 1. But for the next index, I have 1 plus 1 is 2, module 2 is 0, and these wins 2 plus 1 is 3, module 2 is equal 1, 3 plus 1 is 4, module 2 is 0, so this index wins, and so on. And this is very important because we will use these to deform this shape only for these vertices and all the vertices inside of this section minus these starting points. Now we don't need this set position to debug our purpose, our operation. I can select all these nodes, Ctrl J, J, F2, save, boundary, and next step. We want to move these vertices, only these vertices, a little bit up to create a more custom shape of our feather. And to do this, we can use a new stored attribute. We need the set position here, and we need to move only the boundary selection we saved before, but not with this offset, it's obvious. And we want to move up on the z-axis these vertices by the distance between each point from the origin of the coordinate system, multiplying this value by a scale. The result will be this. I have here an index that has this distance from the origin point on the z-axis, okay? And for this, we will have this distance by a scale factor. So, for example, we will have a movement on the z-axis like this, from the origin position of this point. For the next, and the next, and so on, we will have a bigger distance from the origin point in the z-axis, and for that, we will have, starting from this position, a bigger movement on this direction until the end. So, the end point of this boundary selection, we will have the higher distance, so the maximum point over the top of the screen, I think, multiplying this distance by the scale that we will add on the group input. So for this, I can use the group input another time, select group, we can add a new attribute, float attribute called bias from 0, and we can link, described before, from the actual position of these indexes, these points, we can multiply the position with a new vector using the combine XYZ and linking the bias on the z-axis, because we want to scale only the z-axis. Press H and we can link this multiplied on the offset H, select all these nodes, Ctrl J, F2, bias, and you can see the variation of the colors on this surface, because if I select here and hide the annotation, Shift Z to see the surface, I go to shading editor, press tab to exit from the node, and if I increase the bias, you can see this behavior, the stretching of the values of this X, maintaining the correct proportional information between all these interpolated points on the surface, because we will need this next. Shift Z, and you can see if I increase, I have more movement with the last index of the boundary. So here there was this point, and here there was this point, and you can see the changing in between. Okay, this is very cool in the final result, because we will have a stretched hair in this direction, and we will have these points to the center of the z-axis with our shape, with our feather shape, and these will be very cool. So now I delete the annotation, go inside the group node, and the next step, we need to create this particular shape I described a few seconds ago. So now we need to distort another time this boundary selection. So I need to add a set position another time and a name attribute as an input, and I need to select the boundary selection as the boolean and link this to the selection. I want to move only these, and I want to set a new position based by the previous position but changed a little bit. I need a shape that I want. You can change if you want another shape of your feather. You can use the float value to paint the shape of the feather. This could be a shape, a simple shape from 0 to 1. Now we need to maintain the z value of each point, the y value, okay, the y value of each point. We don't want to change those values. We need to only to change the x values, because we want to create the shape we want. Okay, so we need to shift the point on this line to get the correct shape of the feather. So to change in a distributed way the position of these points, I need to remap the index of these points to a values from 0 and 1 to be able to use this float curve node. Otherwise, I can't use it because this node works from 0 to 1, okay, for this factor and for the values that are inside this space. So to do this, we need to link this in an attribute statistic node. We need to select only the boundary selection of our points, and for each point I want the index information, and with this I can use a map range when I can link the index for this value, and I need a range based by the minimum index of these entire sequence of indexes, the maximum of the same sequence, but as the result I want a value between 0 and 1. So the minimum index in this sequence will have 0, the maximum index of this sequence will have 1, and if I link this result to value, this float curve node will set an influence value along the entire values from 0 to 1. So the first value will have this value, the second here, the third, the fourth, and so on until the end, so the last point of this sequence. Okay, now we have a shape like this, but I would like to use this multiplying by a scale value to get an amplitude of the shape of the feather. So I can multiply this value, can move down a little bit, this up, this to the right a little bit. I can use the group input another time, add a new attribute like width and default 1 from 0, for example. I can multiply this value by this value, and now I have to reposition these points with these changed x values, these new x values. So we need to use current position, separate the three vectors. We want to combine and maintain the y and the z values and change only the x. So I want to override only the x values here and link these to the position, not the offset, because we are using the original position. So we want to override these. If I link these, get these values. It's obvious you don't see anything because if I press tab I have no width here, but if I set 1, tada, this is our shape. It's distorted because we are using the bias values, so if I decrease the bias to 0 you will see our original shape. So if I enter here you can see the correct shape of this float curve node on these selection boundary points, and you can decide to create the shape you want. Now you are starting to see the cool effect of the bias, because if I increase these a little bit you can see this particular shape and we will create an effect like this. You are starting to see an effect like this with the final result, okay, because we have the x values distorted. Now I set the 0 for a moment for the bias, tab to enter in this the workflow, select all these nodes, Ctrl J, F2, shape. Now before going to the shading editor to see an initial result of our project, we need two things. One is duplicate these to the other part to create the entire feather, and then add other three attributes to our shading editor. Shift Z, and for now we can transform this geometry. We can link this result. I have vertices here, so I can set -1 for the scale. I can join these with the original shape. Shift Alt and click. This is the result, but keep in mind that with the -1 in the scale, if I enable the face orientation, the orientation is wrong, so I need to add a flip faces here before the joining. Shift Alt and click. Okay, we don't see the other part because I needed to link this geometry to this geometry, and this is the Z information going up to the Z axis. Now I can disable the face orientation, and we need other three elements on our geometry. One is the I don't remember the word, the plucking. So I have the hair, I want to pluck the hair, some hair, and to do this I can store new attribute attribute on my geometry. I can set these the plucking, link these to the group node input. We can rename it in the here plucking from 0, and we can select this node, Ctrl J, F2, save plucking. We can duplicate this entire shape twice. We can link this geometry together and these here to create here the spread color, because I would like to have a variation of the color inside the hair of the feather. So I need here a new spread color from 0. I want to link these here. I want to have a density of my hair, so the repeated pattern of my hair, okay, with a counting. So I can set here the value of count, add a new attribute count from 0 and a base default value of 100, for example. I can link this float number here, rename save color density, and we can start to paint on our feather. So we can go in the shading editor and we have here the Z attribute. We need the X, we need the count, we need the spread color, we need the plucking. Now we have the Z component, so we want to have a texture with a pattern like a wave texture going up like this. We can select this vector and we can link this to a wave texture, shift Ctrl click, perfect. We want hair, so we want a large value here and a thinner value here. So to do this we can multiply the value of the wave texture with these X values. So you see that if I press shift Ctrl and click, we have here 0 and 1 to the end. So I can invert this value, not in the vector, but I want to invert these. Okay, perfect, because I don't want to have the hair here, but I want to have the hair here. For the thickness and for the present, I can add a math node, select multiply. I can multiply this color by this color, shift Ctrl click, this is the result, and you can see the stretching of this result here. You can see I can use the count attribute to set the scale my hair system. So I don't have a count, so I need to go in the geometry nodes tab, go here and count, set 1000 for example, so 50. You can see these in the shading editor. This is the result, and I don't want to have a smoothness, I want to have an hair with a hard corner, so I need to use the grader then to set with this threshold a value like 0 to the smoothest values here. So I decrease the count a little bit, 10 for example, shading, shift Ctrl and click, and you can see these results. These are our hair, and this is our mask to see the hair on this feather. So I will link these to the alpha of my principal BSDF, Ctrl shift and click, and you are seeing the same result because we need to go to the material information, and under the viewport display you need to select the blend mode as the alpha hashed, the shadow on alpha clip, and this is the correct result. But keep in mind that we have a problem, because if I press 1 and select this feather, you can see if I decrease this threshold I have more thickness here and I have a gain with this surface. But if I increase these, you can see the thickness decreases, but I lost the total width I want on my hair. So I need this operation. If you are looking in detail, if I set this to 0.5, the surface that is transparent is the half of the entire side of the feather. So if I increase this threshold, I increase the transparent part. If I decrease the threshold, I decrease the transparent part. So with this information I can flip or create a relationship with an inverted proportion to maintain the correct width of this this shape and maintain the correct length of the single hair. So to do this, I need to link in this threshold my attribute of the thickness, because I stored this on my geometry as a single value. I have no result here because I need to increase these, and you see this result here. So first of all, we need to invert these values from 0 to 1 to 1 and 0, because if I want more thickness and I don't want to increase this value and get a thinner result, I want the opposite. So I need to go here in the shading editor and link the factor in a map range and invert 0, 1 with 1 and 0 and link these to the threshold. Shift Ctrl click on the principal BSDF to see the result. And now in the geometry nodes we need to go to the shape section, because we need to adjust this multiply value, because if I exit from this group node and decrease the thickness, you see the correct thickness, because I have a thinner hair, but I want bigger width. So if I have a small thickness, I need more width. I increase the thickness, I don't need a big changing of the width. I decrease this a little bit. I enter in this group node, and here when we multiply the width with the shape of our side of a feather, we need to divide the width with the thickness and link these to the multiply. In this way, if I increase the thickness, you will have the same or almost all the length of the hair along the surface, changing the surface itself but without any changes on the texture. Now I can increase the counts a little bit, save the project. Now if you increase the bias, you can see this particular effect. To better view this result with this shape, we can subdivide this mesh. So I can go inside the group node, go here and add a subdivision mesh. You can export the level of this subdivide node. We can rename it in subdivision with a number of 2 for the default. Select these two nodes, Ctrl J, F2, subdiv, Shift Z, and we can increase a little bit the subdivision, 4 for example. Now we need to change the position of all these points to create a better result of this mapping, so a stretched values based by a point between 0 and 1. So you need to imagine this bar, and we need to select a point like this, for example, when I want to maintain the direction of the hair, and going up I want to stretch more and more and more and more, and the same down, and I want to be able to move this point to another point from 0 to 1 to have different results. So here I want to stretch the hair up, and from this point going down I want the stretching to the bottom, and you can see if I press Shift Z that this final result is different from this result. Okay, so we will call it bending in our layout. So go inside the section, and for this we need to use 3 new attributes. 1, 2, 3. One that is the bending point, 0.4 for example, from 0 to 1. And this is a float number, a bending scale to have an amplitude of this effect from 0, and a bending spread to stretch more or less some of the points along the boundary from 0. 1.5 for example for the default value, and 1 for the scale. Now that we have these 3 values, to create this bending effect we need to use the original vertical curve before the curve to mesh. Okay, before the curve to mesh, so this point, because we will use this curve as the base of our progress values from 0 to 1 to choose the correct point on the entire surface. You will better understand on a moment. I need the position of what? Of the point on the original vertical curve. So I go here and take this curve. I link these to this sample curve because I want to use the bending point here with the group input. I want get the position on the bending point of this curve to influence all the points up and all the points down of what? Of the entire surface of this feather. So to do this, I create two dots here. Okay, this is perfect. And the idea is this. I want to calculate for each point on this surface. So for this point, for example, I want to calculate the distance between the z value and the point here, multiply this distance by a scale, and in this case, if I subtract from this z value this z, I have a positive number. So if I multiply the positive number by a scale, I go up. The same for these points. So if I select this point and subtract the z components of this point and this z of this point, this bending point, I have a negative number. And if I multiply this negative number by a scale, I go in a negative direction of the z-axis. Okay, so it's three evaluated values that I can get with a simple subtract operation. But it's not finished because we want to move more and more this boundary selection. We want a value that can influence the moving, the shifting of all the points of the surface, increasing from 0 to 1 from this line to these lines. So I want a big influence here to the external part of this feather and zero influence on these points. So I want to maintain these points here or this here, and going to the external part of the feather, I want to get more and more shifting. Now here I have the correct position in the space on this curve. So if I have here a bending point of 0.4, I have 0.4 point of this entire curve. So maybe here, more or less. Now I can capture the attribute of this geometry, and what attribute I want to save the position, the actual position of each point on this geometry. All of this I want to separate this vector to get the z component, the same for this position. I want to subtract from this z information the z information of the bending point to get the correct sign and the amplitude of each point to the correct side. And because I want to move not this part, I need to multiply this value by the influence that I want to distribute on these points. I know that if I press Shift Z and I go to the shading editor and press Shift Ctrl click, press Shift Alt and click to see the material, you can see the values of our X attribute on each point interpolated on our surface. So we can multiply this value by the X attribute of each point, and you will get small values here and a big value here. So I can get the X information and multiply this by this value here, combine these together on the Z values, and we can use another set position node in between, linking these to the offset. This is the result. Now you can see this particular effect because we need to use a duplicated group node to multiply the X by the bending scale, because we want a more or less amplitude. So I need to multiply this first by this bending scale H, then multiply this by the subtract, and I can exit from this node, set bending point to 0.4, and you can see the correct scaling of each point. Shift Z, and don't be afraid, you are seeing that these points go out more easily than these points, but because you have to imagine that this point was in the original point here, not here, but here. If I enter in this layout and temporarily disable the set position of the shape with M, you will see the correct increasing and influence of the values on this shifting. And if I delete the annotation, press tab, if I increase the bending point, you can see the correct shifting of the values, because I'm moving the bending point, so the initial point, and if I increase the scale, you can see some points remains to the same position. If I increase the point, so I go here, you can see small stretch effect up and a bigger stretch effect down, because I have a higher bending point. So now I set this 0.4, bending scale to 1, Shift Z, and you can see the X value here. And if I show you the Z component, so this, you can see the Z component stretched here. Shift Control and click on the wave, and you can see the hair. Shift Control on the principle, going geometry nodes. And if I enable the set position of the shape, you can see this effect. Shift Z, and this is the stretching of all the points. But you can see I have a linear stretching, so each point of each of these curve has a linear amplitude of the shifting from the bending point. I want to change these with a power, and I want to set more power to these values, to the external values, and a low power to the internal values. So to do this, because I don't want to see a perfect line here, I want to have a little bending of each hair on this surface. So to do this, I need to go here and use the new bending spread in this way. I can use a map range, because I have a bending spread from 0. I want for 0 value power of 1. So if I multiply this value with the power of this result, with 0 I want 1. So these values at the power of 1, I have the same result. So I can link these and nothing changed. And if I have 1, I can set here, for example, 2 as the exponent of this powering. You absolutely need to deselect this clamp, because I can set here for the bending spread a value higher than 1. Now if I exit from this and increase the spread, you can see this particular effect. So Shift Z to see the points, and you can see the power mathematical operation. And if I increase these, you can see the stretching is more distributed, because I applied powering for each of these points and I have a more stretched values. If I press Shift Z to see the result and increase the subdivision, you can see this beautiful result. I can decrease a little bit the thickness and set these 1.5 for example. I can increase the counting, I can increase the thickness, turn it on the bias, 100 for the counts, and this is the initial result. Okay, now we can go to the next step, and entering in this layout we can select all these nodes, Ctrl J, F2, bending. Now we can create a color ramp to our feather, so go in shading editor, and here we can use the X values. So if I press Shift Ctrl and click, you can see these values from 0 and 1. So I want to create a color ramp to override these colors. I can move this node a little bit, I can move this node here and here, invert these two values and link this color to a color ramp, when I can set some color like blue, or we can create a rainbow, for example, so blue to the left and red to the right. Okay, complete blue value, so no red. Select the HSV value here and select here far, and this is the rainbow. Link the color to the base color, and this is the result. If I press Shift Ctrl and click, you can see this, and you can move this red to create your custom colorized surface. but it is not so realistic, so we can deform this ramp using a noise texture. We can create a noise texture here. We can multiply the factor or the color or the factor of our x values with this noise texture. So multiply these with the factor and then link the result in the color ramp. We can decrease a little bit the detail and increase to 1 the roughness, and shift control click to the noise texture. We can use the attribute spread color here to manipulate the value of the scale of this noise texture. So I can link this factor to the scale, and I can go to the geometry nodes, tap to exit, go here and set 5 for example, or more if you want. Go in the shading. We can adjust the direction of this noise texture with this vector attribute, so we can use the z values. So if I press shift control and click, you can see the z value that has changed because I used this bending scale. So if I decrease this bending scale, you have these. If I set 1, this is the result. If I decrease the spread, you can see this particular effect, and I can use these values that increase from 0 to 1 going up following these curves in the shading editor to deform the noise texture. So I can link the factor in the vector of the noise, shift control and click, and this is the result of the noise. With M I mute this attribute, and this is the original noise texture. If I unmute this, I can modify the direction of this noise following the values of the Z attribute that goes from 0 to 1. Here I can use the factor, so I used the color, but I can use the factor, save the project, and with this I can select now the principal BSDF to see a better result of the spreading effect of my rainbow. I can decrease or increase my values here a little bit. I can collapse this attribute, and now you forgot a last attribute, that is the plucking. Okay, the plucking that we can create using another noise texture. We can link the plucking factor to the scale, the same z value to this vector to let the noise follow these values. We can set 0 and 0 for the rest of the attribute, and this is the result. We can increase the plucking value a little bit to see something. You see the result. This is the result of this attribute. This is similar to the spread color effect, but this is another attribute for another purpose. Now I can go to the shading, and we can multiply the result of this count effect, so the wave values that I decrease for a moment from 100 to 20 for example. Okay, so we can see in detail the effect of this new attribute, and I can move this a little bit. Okay, the spread color up, and now I can move this here, make a little dot, move the Z a little bit. I can create another dot here and link the vector here. This is the new layout, and we can multiply the result of this X. So this is the X, this is the invert of the X, and we multiplied these values by the counting, so the wave texture. So the wave texture multiplied by this invert is this result, because we want this single hair. Then we have the threshold that cut off the smoothness of this hair, and here we want to cut random hair by the multiplication of this multiply result with this factor of this new noise texture. So we can multiply this value by this factor and link this value to the greater than, and this is the result. Okay, because we multiply this result here with a noise that contains values of 0 and dark gray, light gray, white, etc. And the result of this threshold give us this random effect. Now we can move this a little bit, collapse this node, collapse this, Ctrl Shift and click, save the project. This is the result, but now we have to adjust a little bit some nodes, because if we know exactly the work of the nodes, we know how to use it and how they work. So in this case you can see these values, so I moved this pin from 1 to this value to see the red value here. I don't want that, I want to stay here, and I want all the rainbow into this surface. So to fix this problem, I have to adjust two things. One is this multiply. The multiply multiplies values from this attribute and this noise texture. So if I press Shift, Ctrl and click, you can see the gradient from black and white here. And if I press Shift, Ctrl, click in this noise texture, you can see these. And this is the result, so the multiplication. But this is not a distortion of these values, is a mathematical multiply operation. And you can see this because if I go in the geometry nodes and set the spread color to 0, you can see this result here. This is not the original X values. In fact, if I go in the shading and mute this multiply, you can see if I mute and unmute this node, you can see the difference, because the noise texture, if I have a scale by like 0, okay, for the spread color, if I press Shift, Ctrl and click, I have a gray value for all these surface. I don't want that. Instead of using this multiply node, we need a mix node. We need to link the factor of this color, the factor of the noise, and in this list I need to set linear light. So linear light help us to deform the source values, how can I say, maintaining the original color value, but adding the noise in the position in the space of that color information. Now I set the factor of 1 because I want the entire effect of this noise texture, and if I press Shift, Ctrl and click, you can see this behavior. If I mute and unmute this linear light, I have no effect from this noise texture, and if I increase the spread color here, you can see the deform effect of each original color of the X attribute in the space, and this is what we want. I set 5, go to the shading, and now we can link the color to the ramp. I drop this node, Ctrl Shift and click, and this is one of the adjustment. Another adjustment is the same approach in the plucking result here. So we don't want a multiplication here. I want a multiplication because I don't want the entire value of the X inverted X values. Here I want to the multiply node because I have the count that has this result, and I want to multiply this by the inverted X because I want to create a dark area in the external part of this geometry. So the result is this, and this is correct. But here I don't want to multiply this plucking attribute, but I want to use the same approach. I need a mix RGB. I link this color or factor to 1 and select linear light. Drop this node and link the color to the grid. Then now if I select this, I get this correct result, and if I go in the geometry nodes and decrease the plucking effect, this is what I want. Okay, this is 0 for the plucking, and if I increase these, I can see this particular effect. It's obvious I need to increase the count 100, for example, to see better the result. Go in the shading and shift Ctrl and click to the principal BSDF to see the entire effect and the color ramp on our surface. This is the result. If I want, I can go into geometry nodes and decrease this value. I can decrease the thickness of my hair, and it's obvious you have a stretching effect because we have the entire shape of the feather that increases. So for now I set 0 for the plucking, and we need a last thing in the shading. You can see I don't have the entire ramp in this portion of the feather because the shape increase the width. In fact, if I increase the thickness, you can see the entire color ramp. If I decrease these, I have the red color here, and I lost part of the colors of my color ramp. So I don't want that. I want to remap the result of the color ramp to follow this corner of the shape. And we know that this corner, if I set 0.5, gives us values that are related to the shape of the feather. So if I set here 0.75, you can see I have only 75 part of the feather on the entire surface. So I need to decrease the color in this range. So I need to add a map range here. I need to link this color information, and I want to remap these values to get the correct ramp output to link in this color ramp. So if I leave this here, you can see if I increase the from min, I don't have a good result because I need to decrease the from max to decrease the range input and stay in the same range output from 0 to 1 in the color ramp. So you know that this node works from 0 to 1, okay? So I have this output that is correct, but I have to manipulate the input. You can see the from max needs to be the same value as the thickness. So if I go here and I have a 0.75, if I go here and set 0.75, I have the entire color ramp. To better see the result, I decrease the spread color to 0, and you can see the entire ramp. If I set thickness to 0.5, for example, you can see these, and if I go in the shading and set 0.5 here, I always have the entire ramp because the input goes from 0 to 75 for the entire values of the x that starts from 0 from here to 1 here. I want to remap only the from 0 to 0.5 to the range 0 and 1 of this color ramp. Now I can link the factor of the thickness attribute here directly in the from max value here and get the automatic and dynamic result. So now if I go in the geometry nodes and increase or decrease the thickness, you can see the correct ramp stays in the surface, and this is what I want. Now next part, if I increase the spread color, you see a symmetric behavior on this feather, and this is not very realistic. So we need to change this spread between these two sides. So to do this, we need to have value for all the points to the left of these axis and another value for all these points to the right, and we have to save these values for all the points on this mesh. So to do this, we can go here after the bending operation, not before, because here we need to change the position of each point and then ask to us what position we have for each point to get the correct value to save in a new attribute. So we need a new store name attribute here, and we can give a name like side. This is a float number, and we want to ask where is the position, so not the position but the x value of each point, if it is less or equal 0, so for all these points, okay, I want a switch node with a float value, and if this is true, I want 0, for example, and if it is false, so for all the other points, I want to save 1, and the output needs to be linked here, and this will give us the correct value of the side. And if we go here in the vertices in the spreadsheet, you can see for these vertices, if I go here, the side values of 0 and 1, okay, in relationship of the x position of each point on the surface. Now we can go in the shading editor and we can see these values. So I can add here a duplicate of this node, set side here, shift control and click, and you can see perfect black value, so 0 value for all these points and 1 value for all these points. And you can see here we have a little ramp. I think there is this behavior because Blender needs to interpolate the value from 0 and 1, passing from this 0 number to this point on the space, but this is not a problem because for security reason we will use a greater than node, so I can drag the factor because we don't have colors, we have a single value like a factor, and we can add a greater than with a threshold of 0 to correct values of black and white. Now we can easily add to the Z values here, so if I press shift control and click to the Z, you can see this mapping. Okay, we have these 0 values that increase in this direction following these curves going to this direction. We can separate these two sides, adding from this factor the side that we have here, so I can add the value of 1 to one side, create a dot here, link this dot here, and link this value here to get a correct separation for all these three cases. So for the spread color, in fact, if I press shift control and click, you can see a shifted spread effect here. If I press shift control and click on this, you can see a little different counting here in the center of this shape. And if I press shift control and click in the noise texture, and if I go in the geometry nodes, shift Z to see the texture tab and increase the plucking to 80, for example, you can see the correct shifting from one side to the other side. It's obvious from this point, okay, to the final point there is here, and this gives us in the shading editor the correct result. If I press shift control and click on the principal BSDF, you can see a more accurate spread color, plucking, and counting on this entire feather. Now it's time to join the feather and the base. I can change this color ramp a little bit to get a more realistic feather. Okay, perfect. Now we can go in the geometry nodes, enter in the node group, move this a little bit, and we can join the base result here with a join geometry, and we can link our side. We can select all these nodes, Ctrl J, F2, save side to separate shading effect. Now we link the geometry here. It's more correct, link the output of this set material in the geometry and not here. And we can now export this material in the group input, and we can rename it in feather. Select all these nodes, Ctrl J, F2, feather material, perfect. Now we can move this here, and after the join we need to deform our feather, and to do this we need to save other information on each point. So now I'm going to create the set of nodes that we need to move all the points in the 3D space to make this feather more realistic. Shift Alt and click to see the geometry, the entire geometry, so the base and feather. And for practical reason, I set the plucking to 0 to see all the hairs. Now what we want is to deform the feather with an influence that increases along the direction of each hair. So I want a distortion like this. I want a little distortion here, a bigger distortion here, and then a little distortion here. And going to this internal, I want a little bigger, and then here a little values, and here I want nothing. I want no influence to the distortion in the space of these points. Now you can see from this point of view that if I press 1, you can see I have more influence of the noise to the external part of the feather and a lower influence in the center. So if I go to the shading editor and press Shift, Ctrl and click on these X values, you can see perfect result. So I have 0 influence here and the maximum influence to the external part. So we have one of two information that we need to create this particular noise. The second information that we need is a value that starts from 0 here, from the starting of the feather. So here the starting point of the hair, and we want this value going from 0 to 1 here and then go to 0. And to do this we can use the value of the Z attribute, because if I press Shift, Ctrl and click, you can see the correct gradient from 0 to 1 here, but with a little mathematical operation. Do you remember the ping pong mathematical operation that we learned in my previous tutorial? Well, we can use this mathematical operation. We need to input the X values, duplicate these because we want the Z values. We want a noise texture because we want to move the points in the space, and we need to set the position of the entire feather, so for the base and for the hairs. Shift, Alt and click. We can link the geometry here in the geometry. Now we have the noise texture here. We can set 0 for the detail and 0 for the roughness. We need to add two attributes. So one is the float value of the noise from 0, for example, and a second attribute like the noise offset that we can use to manipulate this noise texture. So we can select 4D for this purpose, add the group input node and link the noise value in the scale and the noise offset in this attribute. Now we have an entire noise, but we want this influence only for the multiplication with these two attributes. For this we need to subtract to this node 0.5 because the noise texture starts from 0 and propagates the effect to the positive space of all the three axes in the environment, and we need to shift the origin point by 0.5 to have the correct starting 3D space for this noise texture effect. There are lots of videos that can describe this need. Now we need to multiply this noise by the direction that we want to use to move all these points in the space. So we need to move these on the normal of the surface. So we can add the normal information and multiply this direction with this vector. Perfect. Then we need to scale this value using the X attribute because we want no influence to this line and we want one influence to the external part of this shape. So we can set this, but we also need the Z component. So to use this Z attribute, we need to manipulate the value passing through the ping pong mathematical operation and dividing the result for the same value here. So if you remember the bending effect we added before, if I go out from this node and increase the bend scale, you can see this effect start from this bending point. So we can use the bending point from 0 to 1 to detect the correct maximum influence on the z-axis for our noise effect. So I can use this value, and for this I can enter in this layout, get the group input node, and link the bending point here for the ping pong, shift right button to create the dot, and link this value also for the divide value. Now I can multiply these x and z attribute together and use the result of this output to connect the scale node here. I move this a little bit to the right, this a little bit, and we can link this scale vector to the offset, and this is the result. Shift Z to see the correct result. Now if I exit from this node and increase the noise value, you can see the noise effect on all the points of the surface with a correct influence from 0 to 1 going on the x-axis and on the z-axis. So you can see the result here. It is exaggerated, but you can see the correct final result. Shift Z to see the final effect. Now I have to go in the shading, shift Ctrl and click to the principal BSDF to see the effect, increase the roughness to the maximum values, go to geometry nodes, and you can see the effect, total effect here. So 7 is very high, I can set 1 for example, and you can see if I move the noise offset, I can animate this feather as I want. Tap to enter, select all these nodes, Ctrl J, F2, detailed noise, and we want another noise to all these points, but in this case I want to have an entire noise, a similar effect like a curling of this feather. Okay, so I want an influence from 0 to 1 going up in the z direction, and to do this we need to save another attribute information on all the points, because we want another influence map on this surface. To do this we need an attribute float value noise base, for example, and because we need a new value of the influence, we can't use the z information, because you can see in the shading, if I press Shift Ctrl and click on the Z attribute, we have no gradient starting from here to here, from 0 to 1, because we have a stretched gradient color, because we have the bending attribute. So we need a new map of the Z from 0 to 1, and because we have the base structure of our feather, we don't want the 0 to start from here, but we want the 0 influence from here. We want all the points below this point to have 0 information saved on each point, and then we want to have the gradient starting from 0 and go up until 1. So for this purpose we need to save a new information where before the detail noise, because we need to calculate the Z position before the detail noise, store this information for each point, and then use for the last noise effect. So in this case we need to go here between the join geometry, because we want to curl not only the feather but also the base of the feather. For this we can start to add a store name attribute, and link is here. It is a float number that will have values from 0 to 1. We can set these absolute underscore z, and now we need to ask what is the z position of each point. So we want to remap all the z position from the minimum z point here and the maximum z point here. To do this I need an attribute statistic node. We need to link the geometry here. We want a separated information of the position of each point, so I need to separate this information. I want only analyze the z component, h, to collapse this this, and I want the minimum and the maximum, and I want a map range where I want to link in the value attribute the z of each point, and I want to remap for the minimum value 0 and for the maximum value 1. I can start to save this information here. I can see it in the shading because I can add a new duplicate attribute here. I can set absolute z, shift control and click, shift z to see the result. You can see a perfect values from 0 to 1, a perfect gradient from 0 to 1 for all the feather. You can't see the same effect on the feather base because we selected the feather and not feather base. This is the reason that we don't see this gradient on the base but only on the feather. Go in geometry nodes and you can see this particular effect here. As described before, we don't want the gradient starting from here and go up because we want to maintain an influence of 0 to the starting point of the feather. Okay, so we want this maintaining the starting point hold. To do this, we needed to go here where we have the absolute z, and we need to get the starting point of the base of the feather. So before the join geometry, we can make a dot, duplicate the attribute statistic, link the base of the feather here, duplicate the position and separate XYZ another time, move it up, link the Z component to the attribute of the attribute statistic, because from this base we need the minimum value of this map range and not the minimum value of the feather itself. So we can link the minimum value here from min, and doing this operation you can see before the starting point of the base we always have 0 influence and up until the end of the entire shape of the feather. We can select this node, press Ctrl H on this. We can move the nodes a little bit. We can select all these nodes, Ctrl J, F2, sort and save absolute Z from 0 to 1 from the base. Now we need another value before making the base noise, because we could probably have more feather than 1 in our environment. For this reason we can go here before the detail noise. We can move a little bit this section and we can let the user set an instance on point directly in this group node and manage the component outside this group node. So we can import the group input, so we can link these on the instance, link these to the group input, link the rotation to the group input, Ctrl H, link the scale at the end of the group input, Ctrl H. We can rename points like instance points, select all these nodes, Ctrl J, F2, instancing, and with this operation we can store for each instance a value like random, so one value for instance, one value for each feather with a random value from 0 to 1. Then we can realize instance to again get not instances but vertices, edges, faces, etc. So the original geometry before the instancing operation. We can select all these nodes, Ctrl J, F2, save random per instance. Then we can link these realized instances on this detail noise, and in this selection I need to select instance, not point, because I need a random value for instance. And you can see anything because we need to go out of this group and create a single point to have the instance and see the feather itself. Tap to enter in the group node, and now we can use these two information, the absolute Z and the random value, to create another shifting, another noise starting from from the base. So we can add a set position, link here, Shift Alt and click. We can import a noise texture. We needed to subtract the common value of 0.5 to remap in the space the starting feature of the noise texture. Then we can scale this value by the name attribute saved before, so the absolute Z. This way we have here the gradient of the influence between 0 and 1 on this noise effect. Link this to the offset. We needed to set 0 and 0 here, and we can select 4D here because for each feather we want a different W value here, a different shifting of this noise to have a different effect for each feather. And we can use the group input, so the noise base attribute, to set the scale of the noise. I select this name attribute, Shift D to duplicate it, select random, link these to the W, but random is a number from 0 to 1, so I can see a very high difference if two feathers are near. So for this reason I can multiply this value by 100, for example, and then link this to the W to have more shifting based on this attribute. Now I can select all these nodes, Ctrl J, F2, base, noise. I can go in the shading editor and drop these with Ctrl X, Shift Ctrl and click on the principal BSDF to see the entire result, and this is the effect. There's one last thing to do. Go in geometry nodes, you can see this feather. If I press tab and increase the plucking factor 100, for example, you can see this bad result here on the corner of the feather, and this is because in the shading we have here the multiply node with the inverted attribute of the X. So if I press Shift Ctrl and click, you can see these after we have the inverted influence, and we have the multiply before the linear light of the noise of the plucking feature. So to avoid this bad result, if I click here, we have these. We need to invert the position of these two nodes. So I need to link the color here and then the result of this linear light in this multiply, and link the output of the multiply in the greater than, because we need at the end the effect of the influence of 0 here on the corner. Now if I press Ctrl Shift and click on this multiply, I have the correct smooth hair at the end of the shape. And now if I press Ctrl Shift on the principal BSDF, I have the correct result on the feather. It's not finished because now if I go in the geometry nodes and add more points to my environment and use the index as the position of each feather, so this is the first and this is the second, you can notice the correct difference of the spreading effect of the color on the feather, but these two feathers have the same pattern. So for this reason I can go in the shading, and here where we have Shift Ctrl click the values of the side, so after the greater than, here we have 0 and here we have 1, I can move this a little bit and I can add a value based on the random attribute that we saved before, random, multiply this by an high number to have a more gap, like 1000, for example, link this to the add, and then this result here to add the value with the Z attribute of our UV map. We can collapse these, select all these nodes, Ctrl J, F2, feather separation, and with these, if I press Shift Ctrl and click on the BSDF, I get a different result for each feather, and this is perfect for our purpose. In a weekend instance, for example, an icosphere instead of points, delete these and use the normal information to align the z-axis of the original feather to this normal information and link the rotation to the rotation. And if I increase the subdivision and decrease the radius to 0.3, I can have this result. And you can manipulate the rotation scale of all these instances, getting a different effect for each feather of this environment. We can increase the noise base a little bit to have a more random style on this environment, and this is the tutorial. Thank you guys for watching this video. I hope you enjoyed it. If you like what I'm doing, please subscribe to my channel and check the bell icon to get notification of all new posted videos. See you next time. Bye.